Hey, and welcome back to Wheat Beat. My name is Mike. I was starting a recipe the other day and it said in the recipe, do not mix the salt with the yeast. Supposedly salt kills yeast. Is that even true? Sounds to me like it might be another one of those myths that I'm going to need to debunk. So join me today and let's find out if it's true. Today we are going to find out, does salt actually kill yeast? And we're going to put it to the test. The way we're going to do it is make one batch of bread, white bread, very simple. And we are going to add the yeast in 3 different ways. First way is just the conventional way where we're going to add the yeast to some pre-measured amount of water. We're going to let it activate there, and then we're going to add the salt separate, the way you would be normally asked to do a recipe. The second way is we're going to add the yeast into water that has a lot of salt in it, and I'll put in the comments down below how I did this exactly to make sure that it was a fair comparison. But you'll have to trust me on this. The third one is I have a less water with the same amount of salt. So this is a super saturated mixture of salt. In fact, there is so much salt in this one right here that it's out of suspension. So you can actually see salt granules in there that I could not get into the water. We're going to mix the yeast into that one. It couldn't possibly be more salty than this one here. Then we're going to add all of these into the thirds of the batch that I make of bread, and we're just going to bake it off like we normally would. And then afterwards, we're going to compare and see, did this one, in fact, the very, 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 very salty one, kill the yeast? If it did, we would expect that the bread doesn't rise at all, as opposed to the one here where we added it the quote-unquote right way. So let's get started and find out what happens. So right now I'm putting together the main dough, and this is going to include everything except for the salt and the yeast like we discussed. So once I develop the gluten here, we'll divide this into 3, and then we'll add those things in at the end in exactly the same way. Okay, so I've gone ahead and divided the main dough into 3 identical pieces. I've measured it down to the gram, so they are precisely the same weight. So now I've added the yeast to the water. We have 50 grams of water here, and the salt is on the side. So 10 grams of yeast and 50 grams of water over here, no salt. Over here we have the same amount of water, 50 grams of water, 10 grams of salt, and 10 grams of yeast. So all of the yeast that's supposed to go into the dough. Over here we have only 10 grams of water and 10 grams of salt and 10 grams of yeast. So this is the super saturated, extremely salty version over here. I actually have a little extra water over here on the side so that it makes up the difference, so that I add the exact amount of water to each of the doughs. Here the salt is on the side because I haven't added it here at all. So we're going to let this activate here for about 10 minutes. And then we're going to add each of these back into the doughs that I showed you before, and we're going to see what happens. Okay, so it's been 10 minutes, and what I can see is that the one that didn't have any salt is a little bit foamy. It didn't rise much because this is room temperature water. It's not really around 115 degrees, which is more appropriate for activation. But this is instant yeast, so it doesn't require activation. More on that in our next video. But all I can tell you is that this is a little bit foamy. It definitely looks like the yeast is active. This one here that's a little bit saltier, it certainly doesn't look foamy. It doesn't look like really anything happened here. I wouldn't necessarily expect anything to happen here. It doesn't mean that the yeast is dead. It just may mean that the yeast didn't have any activity because of the saltiness. Same thing goes here. This is the one that's extremely salty. Really no activity that I can see. So we're going to start with the super salty one, add this into the mixer, mix it for the exact same amount of time between each one, and then we're going to let it proof. So let's move on to that step. All right, so here's one of our increments, our 1/3 increment. I'm going to add the water to here right now so that it's the same amount. And then we'll add this slurry in, and I'm going to use piece of the dough here to wipe the inside so that I make sure that I gather up all of the yeast that's inside here and all of the salt so that I'm getting the correct proportions into this dough. And then we're going to mix this all together for precisely 3 minutes, and then we're going to do the same thing for the next increment and the next increment. All right, so here we have all three batches in separate trays. This is the super salty one, just the regular salty one, and this one was done in the normal fashion. They are going to bulk ferment in here at about 75 degrees Fahrenheit for an hour, and we'll take them out and get them in the proofers. Okay, it has been an hour now, and that one is the super salty one. This one is just salty, and that one is normal. One of the first things that I can see is that the super salty one looks like it's spread out a lot more like a pancake, a lot more smooth and flat than when I compare it to the normal one here. Now, when I was actually working on this dough, I did notice that the one that was super salty was a lot more stretchable, or what we call extensible, and I wondered why that might be. And I'm actually starting to create some thoughts in my head on why this one is so much more flat. Maybe you might have some ideas too, but we'll explore that more as we continue. I'm going to split each one of these into two. I'm going to then put them in their own tray like that there, and then we're going to proof these for 2 hours before we bake them. Okay, and here we are now after the proofing. This one is done the conventional normal way. This one is with what we called salty, which doesn't mean there's more salt, just the way the yeast was activated. And this is the one that we called super salty, and clearly there's a difference there in how they rose. We're going to go ahead and get these in the oven now, and when they come out, we'll talk more about the results and what may have led to these results. Now, one other little note to make, if you want to be sticklers, is that I didn't put all the breads on the same shelf. I sort of varied it, so there was a salty on the top and a salty on the bottom, and then a super salty on the top and the bottom, so that they were all kind of in different positions, so we couldn't attribute a result to the position in the oven. Okay, so the results are in, and here they are. This is the one where the yeast sat in a tremendous amount of salt for 10 minutes. Here it sat in a slightly less concentrated amount of salt, and this is what we call normal, which means we only added the salt at the same time that we added the yeast into the dough. So clearly there's a difference between them. This one from the top probably looks what I would say the least like the normal bread. This one looks a little more rise and a little better shape, a little more rectangular. This one is a lot more lopsided, and this one here is what we're calling the control, or the one that we would do normally. I think the first thing you're tempted to say here is that the yeast was killed by the salt, but I don't think that it's easy to draw that conclusion so quickly, and I'm going to explain why. So as you saw at the earlier stage, the dough looked a lot more flattened out, or what we're calling extensible, or even weaker. And what caused that to happen is pretty much my theory, and I'll go ahead and explain it to you, but I'm going to stop right here and say that if you don't want to hear the nitty-gritty and all the details and chemistry and all those probably boring things to most of you, just tune this out or fast forward a little bit, because I'm going to get into some details. So what would make a bread flatten out like that or look weak? That would normally be something we call a reducing agent. A reducing agent is opposite from an oxidizing agent like ascorbic acid, or otherwise known as vitamin C. Those oxidizing agents make gluten, the strands inside the gluten, stronger, and it can help the bread rise higher, but it also makes the bread harder to handle. The dough is harder to handle because it's more like a rubber band sort of consistency. You try to stretch it out and it wants to go back to its original shape. So it's hard to work with, and that's why in a lot of cases, especially commercial operations, they add reducing agents to make the dough easier to work with. Reducing agents that are commonly used are ones like L-cysteine, or a sodium bisulfite, or sodium metabisulfite. And obviously this is not super interesting, but the fact is that it's used in a commercial setting, and it's used to make the dough a little bit easier to work with. Now, what else is a reducing agent? Inactivated yeast. So when you take yeast and you inactivate it, you make it no longer a functional yeast cell, it actually secretes something called glutathione, which is a kind of a protein material, which ends up interfering with the disulfide bond in gluten. Now, I know I'm getting very technical, but gluten strands hold together by something called disulfide bonds. And if you disrupt that bond and replace it with what's called a thiol group, it basically makes the gluten weaker. And that's exactly what a reducing agent does. It's what that glutathione does, and glutathione is what comes out of yeast when you disrupt them, when you inactivate them. So what this all means, now we're kind of back, if you skip the boring part, is that if you add a reducing agent, you get less rise, not just because you have less fermentation and yeast activity, but because the gluten is weaker. And I think that that is actually explains a big portion of what happened here on the left side. It's not that we killed all the yeast. Clearly we didn't kill all the yeast. Had we killed all the yeast, we would have gotten no rise at all. There is fermentation here. The yeasts were not all dead. They were probably partially dead, or a portion, a certain percentage of them were dead, and those dead cells, those dead yeast cells, ended up secreting glutathione, which is a reducing agent, which made this flatten out and rise less vigorously. There was also less yeast cells that are viable in there, which means less carbon dioxide and less rise. So I think it's a combination of the two. So what is really the conclusion from all this? I think it's safe to say that if you put your yeast in an extremely concentrated slurry of salt and you leave it there for 10 minutes, you're going to partially inactivate or kill those yeast cells. Not completely, but you're going to partially do it, and you're going to be adding a reducing component to your dough, which is going to make it easier to stretch out but not rise as high. Will salt actually kill yeast? I think what we've shown here is that salt will kill yeast, but it has to be very concentrated and over an extended period of time. For most formulations, when you see them say, don't put in the salt and the yeast at the same time, I'm going to say we kind of debunk that. Because if you put in the salt and the yeast at the same time and then just start mixing the dough right away, I honestly don't think there's going to be any effect whatsoever, and you can probably just ignore that advice. Now, I can only prove that to you if I ran an experiment where I did exactly that, but I think I have enough information here to be able to confidently tell you that that is the case. Now, there is some advantage to inactivating part of your yeast. You could have added more yeast at the same time, and so you would have a percentage of them that would become inactivated or dead, but there is a percentage of it that's still active. And if you had just increased the amount of yeast, you would have just ended up with more viable yeast and also more non-viable yeast. Now, what is the advantage of inactivated yeast or non-viable yeast? Well, the advantage is that it adds more protein to your bread, and it also adds more flavor. There's like almost like a cheese-like flavor to it when you add inactivated yeast. There's also additional vitamin B specifically that comes with that as well. So what I'm going to guess here is, I haven't tasted any of these yet, but I'm going to guess that as I get over here to this one where there was a lot of a reducing agent, I might notice that the flavor here is slightly different than over here. So I'm going to try that out and let's see what happens. So this one here is my control. It tastes good. It tastes just like what I would expect normal bread to taste like. This is the one where we put it in a salty but not super salty environment before we added it to our dough. Now I'm going to be honest, the texture, the crumb here is a little bit more dense. I don't taste any difference whatsoever between the two. Now let's try this one here. Also, maybe my palate is not very sensitive. I can definitely taste or feel the difference in the density of this dough, but again, it tastes identical to me. So I think flavor-wise, theoretically, this one should have a slightly stronger flavor to it, like maybe a little bit more cheesy-like, yeasty-like, I suppose, flavor, but I don't really taste it. So what else could we have done here? We could have done another experiment where we only added a reducing agent like L-cysteine or something of that nature, and then added the normal amount of yeast and saw if we got if we basically got a result that looked like this, which would have proved that we actually didn't inactivate the yeast cells hardly at all. We mostly just added a reducing agent. I know it's very confusing. Most of you have probably dropped off by now. So let me just summarize it like this. If you add yeast and salt at the same time, it's going to be fine. If you slather your yeast in salt and leave it like that for 10 minutes, you're going to see an effect. Most of you are not going to do that. The surprising conclusion to all this is, even though these look different, I truly believe that if you add salt and yeast at the same time and start mixing your dough, you're going to see absolutely no effect whatsoever, and you can ignore the recipes that tell you otherwise. Until we meet next time, go out and bake something.